the song stopped and the announcer came on, and the announcer said, "This is a special weather bulletin." And I went over to the radio and I started to listen. And the announcer went on to say, "A tornado watch has been issued for this area. Big thunderstorms are building to the west of us, and these storms may contain large hail, damaging winds, frequent dangerous lightning, heavy rains that could cause floods, and possibly tornadoes." So I'm listing all this stuff and I'm thinking to myself, cool. We've got lightning and hail and floods and tornadoes coming. I got to check this out. So I went over the window and I started looking outside. Well, boys and girls, this was getting to be toward evening time. So you know how it is when it's starting to get dark outside and you have the lights on in your room? It's kind of hard to see through the glass in the window because you get glare and reflection from the lights. That was the problem. I really couldn't see out the window very well. So I figured, hey, what the heck? I want to see this big storm. I'll just open the window and get a better look. Now, when I opened up the window, all the nice, cool, air-conditioned air went out, all the hot air came in, but I didn't care because I wanted to see the big storm. So I'm standing at the window now and I'm looking outside. Do you know how it sometimes gets before you have a thunderstorm, before you get the wind and the rain and the hail, it'll get really quiet and still. We call this the calm before the storm. And that's what was happening. There wasn't anything going on outside except way out in the distance, I could see this dark cloud. So I figured, hey, that's got to be the big storm. I'll just watch it and see what happens. So I'm standing at the window and I'm watching and I'm waiting. And this cloud starts to get bigger and darker and closer and closer and darker and bigger. And as the cloud was getting closer to me, I kept trying to get closer to the cloud. Finally, I'm right up against the window like this, got my nose pressed against the screen. I'm looking outside. Well, by this time, the sky was really looking nasty. Big old dark cloud. I could see some lightning. I could hear some thunder, but there was still no wind and there was still no rain. So I kept waiting and watching and listening. And all of a sudden, I started to hear this roaring sound. And the roar started kind of faint at first, but then that roar began to get louder and louder and louder. And pretty soon it's really roaring outside. I'm right up against the window like this, and all of a sudden the storm hit. And the wind came whipping in my room. The curtains are flying. It blows me backwards, and it starts raining. But because my window is open and the wind is blowing in, all the water came pouring in my room. I'm soaking wet. There's water all over the floor. I kind of swam back to the window like this. I get back to the window. I'm looking outside, and the rain's hit me in the face, and I'm looking outside. And outside, it was unbelievable. The trees are bending over like this in the wind. Great big chunks of hail are coming down. Lightning streaking through the sky all over the place. It's raining so hard the streets flooded. And I'm standing there soaking wet. And I said to myself, this is great. And I stood there for the next 10 minutes, having the best old time watching this storm. Didn't even care all the furniture in my room was starting to float around and stuff behind me. Well, all of a sudden while I'm watching this, all of a sudden the sirens went off, the tornado warning sirens. So now I'm at the window going, oh baby, I'm going to get to see a tornado too. So I'm looking around for the tornado when suddenly, from behind, I felt this hand reach up and grab me around the shirt like this and start pulling me out of there. I look over my shoulder, it's my mom, and she's taking me down in the basement. So we got down in the basement, Mom let go of my shirt. I took off back upstairs again. I'm back at the window looking around. All of a sudden, whoop, there's Mom again. We went back downstairs the basement, got down there, she let go. I took off back upstairs again. Well, this went on a couple more times, till my mom finally got tired of the whole thing and she kind of tackled me and held me down in the basement till the tornado warning was over. Now, boys and girls, I tell you that story for two reasons. Number one, it shows you that as a 7-year-old, I was not terribly bright. That was a dumb thing to do. I mean, the last place you want to be, there's a tornado coming, is standing in front of the window waiting for the thing. So I was lucky the tornado didn't hit very close to our house. But the second reason I tell you the story is to give you an idea of the excitement I have for the weather. I think weather is really cool stuff. And I decided a long time ago that when I grew up, I wanted to be a meteorologist. Now, I put that word under my name there, meteorologist, And take a look at that thing. It's really long. It's got a whole bunch of O's in it. And what in the world does meteorologist have to do with weather? I mean, if anything, it looks like I should be an expert at meteors. Well, boys and girls, it's an old word. It goes back to the ancient Greek language about 2,000 years ago. And in that language, the first part of the word, meteor, meant things in the air, like rain and snow and clouds. Ologist means someone who studies. So very simply, a meteorologist is someone who studies things in the air like rain and snow and clouds. And that's where that word comes from. Now, if any of you think that someday you would like to be a meteorologist, and maybe do what I do, present the weather forecast on television, or maybe become the kind of meteorologist that would fly into the eye of a hurricane, or maybe become the kind of meteorologist that would go out and chase tornadoes to get close to them and study them. My friends, if any of you think that someday you'd like to be a meteorologist, let me give you a little advice. Everything you study in school is pretty important. But if you want to be a meteorologist, the most important subjects that you really need to study are obviously your science lessons. But just as important, boys and girls, if you want to be a meteorologist, you need to study your math. It takes a whole bunch of math to become a meteorologist. Big, hard math classes that you have to get good grades in high school and college. Now, I got to tell you something. When I was your age, I was not some great mathematician. Math was not my best subject. I kind of struggled with it. But I knew if I wanted to realize my dream of being a meteorologist, I knew I had to get better at math. And so here's what I did. I made up my mind, hey, Mike, you can get better at this. And I came into school early if I needed to work with my teacher, or stayed after late. I did all of my math homework, all of my math assignments, any math extra credit I could get. And do you know what happened? I got a whole lot better at math. And I bring this up because any of you can do this, whether it's math or science or spelling or reading or gym class. If there's something that you struggle with in school, the way you get better is first make up your mind to be better and then work with your teachers, and you'll be surprised how much better you get. Now, I don't sit there today at Channel 7 as a meteorologist and spend my day doing my math worksheets, but I had to know that math in order to get the job I have now. And now I think I've got a pretty good job. I get to go on TV, I get to try and forecast the weather in Colorado, and I get to come and speak to all of you. And I enjoy speaking at schools because when I come to a school, I get to bring stuff for show and tell. Here's my first show and tell for today. Now, as I mentioned earlier, I speak to a lot of schools, about 100 schools a year, and over the years, the boys and girls have tried to guess what this thing is. And I've heard some great guesses. I've heard bird feeder, I've heard popcorn popper, I've heard snow cone maker, and I've heard hair dryer. But my favorite was one time at a school, somebody said they thought it was a toilet paper dispenser. Now, nothing like that. This is actually a weather instrument, a little gadget that we use to help us forecast the weather, and it's called a radiosonde. I have it written right over here. It's a little faint, radiosonde. I'll get out of the way here. You can see it a little bit better. And the radiosonde is a little box of weather instruments that we use to help us find something called the jet stream. Now, I talk about the jet stream pretty often on TV, and you might wonder, what is this jet stream thing anyway? Let me tell you about that first. You know when you see a jet airplane way up high in the sky and they're just a little speck up there? Those airplanes are flying at a height, at an altitude of about 5 or 6 miles above the ground. They like to fly that high because when you're 5 or 6 miles in the sky, you don't have to worry about running into things like mountains and trees and stuff like that. Well, it turns out the air way up there also has nothing to run into, and there's nothing to slow it down. And so the winds way up high where the jets fly can get blowing really fast. Sometimes the winds up there 5 or 6 miles above us can reach speeds of 200 miles per hour, as fast as a race car. Now, they don't blow that fast everywhere, but instead the strongest of these winds tend to become concentrated into these little narrow, twisting, turning, almost like rivers of fast-moving air. And much like a river of water, this river of air will bend and twist and turn as it flows around the world. Ladies and gentlemen, that very simply is the jet stream, a little river of fast-moving air way high above us. I would say it's easy to remember the jet stream because it's up where the jets fly. That's the first part. And it's a little river of fast-moving air. What's another word for a little river? A stream. So jet stream, little river of fast-moving air way high above us. Okay, I appreciate how excited you are about this. But here is the reason why the jet stream is important. You're thinking, Mike, I don't live 6 miles in the sky. Why do I care? Well, here's the reason why. When the jet stream is blowing over Colorado, even though it's 5 or 6 miles above us, the winds up there are so strong, they stir up the atmosphere a whole bunch and can actually cause storms down here on the ground. Wind storms, snowstorms, thunderstorms, and even tornadoes. So the key thing to remember about the jet stream is actually quite simple. When the jet stream is blowing over Colorado, we get stormy weather down here. Okay, let's all try that out there at home. Ready? Here we go. Moms and dads, teachers too. Here we go. When the jet stream is blowing over Colorado, we get stormy weather down here. Yes. So, in the wintertime, we get 2 feet of snow here in Colorado. Where do you think the jet stream is? It's going right over us. This works in other places too. When they get tornadoes in Texas, where do you think the jet stream is? It's over Texas. If they get 3 inches of rain in New York City, where's the jet stream? It's over New York City. So if we can figure out where the jet stream is, and more importantly, where it's going next, because it moves around, we can make a more accurate weather forecast. But my friends, there's a problem. How are you going to know where the jet stream is? You can't just look up there and see it. It's made of air, it's invisible, and it's 6 miles up in the sky, and it doesn't stay in the same place. One day it might be north of us, one day it might be south of us, one day it might be right over us. How are you going to know? I can't climb a ladder 6 miles tall to get up there and find out where the jet stream is. That, my friends, is where the Radiosonde comes in. This funny looking box is made out of cardboard and plastic. It's very lightweight, only weighs about a pound. But if you open it, on the inside there are a whole bunch of little tiny weather instruments in there. There is a barometer to measure the pressure of the air. There is a hygrometer to measure the amount of humidity or moisture in the air. And there's a thermometer to measure the temperature of the air. You might also see this little circuit board right here, a little blue thing. That actually is a radio transmitter. Underneath the Radiosonde, this cone-shaped thing right here is a radio antenna. The Radiosonde acts like a tiny little radio station. Now, it doesn't play rock and roll music. It doesn't broadcast a football game. What it does is it transmits weather information, temperature, humidity, air pressure, stuff like that. So what we do is this. We send the Radiosonde up into the sky. It automatically gathers the weather information and radios it back down to us on the ground. Kind of like this. If we were pretending it was going up, it'd go up in the air and it'd say, "Hey, Mike, I'm up here at 10,000 feet and here's the weather today." I'd go higher up and say, "Hey, I'm up at 20,000 feet and here's what's going on." So we send these Radiosondes up into the sky every single day to find out what the weather is doing up there and to help us locate the jet stream. Now you might wonder, how do you get the thing up in the sky? I mean, do we shoot it up with a rocket? Do we get a giant slingshot and zing it up there? Do we use a weather balloon? I'm sure you're saying yeah out there, and you're right. We do use a weather balloon, and in honor of our visit today, a double show and tell, not only the Radiosonde, I also brought in a weather balloon to share with you. But before I bring it out, I want to see a quick show of hands. How many people out here think a weather balloon is something really big? Okay, I'm looking. Okay. How many people out there think a weather balloon is something kind of small? Okay. Again, moms, dads, teachers too, I want you to share this vote. I'm going to give you one more chance. How many people out there today never really thought about it before? Okay, I get that. It's not one of the big pressing issues of your day. Well, inside of this box is one standard size U.S. government approved weather balloon. So let me get this out and we'll see how big it really is. Pretty good size, huh? Blow it up? Boys and girls, even with all of my hot air, we don't have quite that much time here to blow the thing up. But here's what I'll do. I'll model it for you. Here are the latest weather balloon fashions as we head into spring and summer. Of course, this season, we think that the weather balloon wrapped skirt will be a must item. We also like the weather balloon cape. And for those chilly nights, you can keep your neck warm with the weather balloon scarf. There we go. What do we actually do? Is we fill the balloon up with helium, which is, of course, lighter than air. You probably have had a helium balloon. You let them go and they take off, except when this one's filled, it's really big. It's about 7 feet wide, about 7 feet tall. You tie off the end so the helium doesn't escape, and then you take the Radiosonde And using some of these strings, you tie the balloon and the radiosonde together, take them outside, let them go, and they take off up into the sky, traveling upward at 1,000 feet per minute, going higher and higher and higher. And as the balloon and the radiosonde go up, the radiosonde automatically gathers the weather information, radios it down to us on the ground, and that is how we figure out where the jet stream is. Now, some of you might be wondering, hey, Mike, this all sounds great, but how do you get the thing back? I mean, you can't just go floating off into outer space. The next part is my favorite part. My friends, as you get farther away from Earth and closer to outer space, the air up there gets thinner and thinner and thinner. What that means is, as the balloon goes higher, there's less air pressure to push on it to keep it the same size. So as the balloon goes up, the balloon begins to expand, and it gets bigger and bigger and bigger and bigger, and finally the balloon gets so big, what happens? It pops, that's right. And this happens way up high above us at an altitude of about 100,000 feet above the ground. So high up that 100,000 feet above us, the air is so thin, you are so close to the edge of outer space, the sky is not blue, it's a dark purple, and the stars shine even during the day. So high up that 100,000 feet above us, there is so little air pressure on the balloon will expand to become about 100 feet wide, and then all of a sudden, pow! The balloon pops, and the radiosonde starts to come back down. Now, I know what you're thinking. Man, I better look out when I go outside. Get hit in the head with these, come home, go, hey, Mom, I had a bad day today, I'll tell you what. Not to worry, because in addition to the balloon and the radiosonde, we send up one more thing, and that thing is a parachute. And as soon as the balloon pops, the radiosonde begins to fall back down. Poof! The parachute opens, and the whole thing gently floats back down on the parachute. Now, even in this virtual world, I can feel the excitement building out there. But wait, it gets even better. We send these up not only from Denver, they are sent up from 100 cities scattered all across the United States, and we send them up twice a day, once in the morning, once in the evening. That means every single day across this great nation, there are about 200 of these going up into the sky. They go way up to 100,000 feet. The balloon pops, the parachute opens, they drift back down on the wind, and my friends, they can land any place. Parks, playgrounds, farm fields, golf courses, parking lots, maybe even at your house. So take a good look, because someday, somewhere, sometime one of these might land in your neighborhood, and now you'll know what it is. And you can't just imagine that. I mean, it's just out there, laying out there in front of the house. Got some pieces of the balloon that are there as well. The parachute's there, but basically the thing is just laying out there. And after a few minutes, the neighbors start coming over to their window, and they're looking outside at this thing, and they don't know what that is. Somebody says, we better go outside and check this out. So they come outside, and they come out, and they're looking at this thing. And other people start coming out of their houses too, and they're looking at this thing. But nobody's getting too close, so they're freaked out, not quite sure what this thing is. So pretty soon there's this great big circle of people around the radiosonde, and they're all just kind of walking around the thing like this. Well, finally, somebody in that crowd gets brave and decides to check it out. And they're walking over to it, and they're getting closer and closer and closer, and they're just about to reach down and pick it up when somebody else says, hey, maybe it's something from Mars. Ah! You get the idea, right? Pretty soon there's this big circle of people surrounding the radiosonde, and they're all thinking your neighborhood's under some type of alien invasion. Here's where you can have some fun, because you are here today, you know what the thing is. Here's what you do. Come out of your house, but when you come out, use your best cool walk. Kind of stroll up to that crowd. Say, excuse me, folks, back off, let me through. Now you will be inside of the great big circle of scared people, and you will be standing next to the thing. Everybody's going to be watching you, so be real calm, be real cool. Say something to the crowd like, don't be afraid, folks. I'll protect you. Then you stroll over to that radiosonde like this. Reach down, pick the thing up, hold it up nice and high, and in a big, strong, dramatic voice say to that crowd, do not fear. It's just a radiosonde. The crowd will yield a collective sigh of relief, and they'll say, thank you for saving us. And then you know what they're going to say? What's a radiosonde? And now you will have that crowd's attention. You can tell about all the instruments inside this thing, how we send it up with a great big weather balloon, how it automatically gathers the weather information, radios it back down. That's the way we figure out where the jet stream is. When it gets up to 100,000 feet, the balloon pops, the parachute opens, it floats back down in the wind, and you've just found it. Whew. My friends, the crowd will be amazed, and they'll say something like, "Wow, you sure are a smart kid." And then you just give them one of these. I'm brilliant, what can I say? Now, I know what you're thinking. I know what you're thinking. You're thinking, man, if I ever find a radiosonde, that is going to look sweet in my room. And you're right, this would be a handsome fashion statement in any room. But there are a couple more things you can do if you ever find one of these, just to prove how brilliant you really are. If you find one of these, it is okay, when we get back to our normal state, to take it into school, share it with your class, and get a whole bunch of extra credit from your teacher. That's okay. If you find one of these, it's also okay to invite all your friends over for a big party, when it's okay again, and celebrate its arrival in the neighborhood. But, boys and girls, after a couple of days, when the excitement over the arrival of the radiosonde is worn off, here's what you should do. Open the side of it right here, and you'll pull out a little white bag. On the bag is some writing. Kind of hard to see there, but this is fragile. Handle with care. And if you put the radiosonde into the bag, you can leave it by your mailbox, and the nice folks at the post office will take it back to the National Weather Service. The National Weather Service can fix it up and reuse it. Important to do, because that is conserving our resources, recycling, a good thing to do. Now, there may be some of you out there that say, I remember when Mike Nelson spoke to my school 30 years ago, and he had the exact same radiosonde. Yes, that's true. Radiosondes have changed a bit over the years. I wanted to show you some of the newer ones, but also tell you a little bit of a story. Many, many years ago, there was a very famous weatherman in the Denver area by the name of Stormy Rotman. And he was on the air in the 1970s and 80s. He was a friend and one of my weather heroes when I was younger. And Stormy actually was a World War II meteorologist that even back then knew the importance of understanding where the jet stream was. He used this exact same radiosonde in the 1970s and 80s to share with school children all across Colorado to teach them about the jet stream. And many years ago, he gave it to me and asked that I continue the tradition. As you might imagine, radiosondes have probably changed a little bit over the years. Would you like to see the newer models? I know you do. So, ladies and gentlemen, a new, smaller version of the radiosonde. Does the same job, just in a smaller, lighter package. We don't need as much helium to get this up in the sky. This is not even the newest. My friends, for 2020, I'll show you the radiosondes. How much smaller they are compared to that. Now, interesting also that all of these are made by a company right here in the Colorado area in the Front Range called Vaisala. And they are one of the world's leading manufacturers of weather instruments, and they build these radiosondes. They're used all over the world. Now, there's one more I want to share with you, and that is this one. This is a very special type of radiosonde that we use to find out what is going on inside of a hurricane. As you might imagine, it's a little hard to send a weather balloon up in a hurricane. But when there's a hurricane forming out of the ocean, we need to know what's going on. So here's what we do. We send out a special airplane called a Hurricane Hunter. Big, sturdy wings, strong, reliable engines, and on board a very brave crew that eats a very light meal before they go, because they will be bouncing up and down in the hurricane for about 8 hours. As they fly into the hurricane, the airplane is rocked back and forth, up and down. The turbulence is terrible. The crew is all belted in, but it's a rough ride. But when they get to just the right spot in the hurricane, they open a tiny hole in the airplane and they drop this from the airplane. As it falls, a little streamer type parachute opens, and this drop zone, as we call it, falls down through the hurricane. All of the instruments sealed inside, the antenna protected from the storm, and it will radio back to us what's going on inside the hurricane. We do not usually get these back because they tend to land in the ocean. I guess you might be on vacation at the beach someday and find one of these washed up in the sand. If you ever do, go ahead and keep it, because we can't reuse these due to the salt water that corrodes some of the parts. But this is what we use to find out what's happening inside of a hurricane. Now, once we have all of that data from the radiosondes and from surface observations from all over, from airports and different weather stations all over the country and around the world. We put it into a computer system, and then we plot it onto weather maps. And these, a little hard to see again, but those are the kind of weather maps that I use every single day before I go on TV. You can look at them on a computer screen, or you can print them out, and I'm kind of old school. I like to draw on them myself and do some hand analysis. Before I go on TV, I study charts like these to figure out what's going on and what the forecast is going to be. And then I use my weather computer systems to create all of the colorful graphics. We talked about that a couple of weeks ago with the changes in the weather computer systems over the years. And then finally it's time to go on TV. Actually takes about an hour of preparation for every minute that you see me on the air. Okay, now it's time for me to perform my favorite part of the show, and that is time for me to perform my tornado dance. Now, boys and girls, tornado dance is a fun way to learn how tornadoes form, but let's remember that tornadoes are very dangerous storms. If I come on TV and issue a tornado warning for your area, please do not do what I did when I was 7 and go stand by the window. That was a bad idea. I was very fortunate, very lucky that the storm didn't hit very close to our house. Here are my tornado safety rules, and they are so simple you can teach them to younger brothers and sisters and maybe even to mom and dad. If there is a tornado warning for your area, rule number 1, get low. Get as low as you can. Get to the lowest floor of the building you're in, get to the basement, get as low as you possibly can. Tornadoes produce a lot of debris. This stuff right here, that's not just a cloud, that's rocks and sticks and broken glass flying around at high speed. The lower you are, the less likely you get hit by that debris. So get low is rule number 1. Rule number 2, protect your head. Get in the turtle position like you practice in school. Get underneath a table or a staircase or under a bed, so if things are flying around, they don't hit you in the head. If you know where it is, grab your bicycle or your ski helmet and put it on. It may sound silly, but people have survived tornadoes because they had a helmet on when things started flying around. And if you're home and mom and dad are still at work, you're home by yourself, and you have younger brothers and sisters that might be freaking out a little bit, having them put on their helmet empowers them, makes them feel like they're doing something to protect themselves. So my tornado safety rule is pretty simple. Get low and protect your head. Now remember this also. When there's a tornado warning for your area, I will be on TV on Channel 7 during the whole time the tornado warning is in effect, if it's in the Denver area, okay? And I will let you know what's going on, so just turn on Channel 7 and I'll be there to give you all of the information. Most of the time, these storms don't last very long, maybe about 20 minutes or so, and then the warning is over, and we'll let you know when it's safe once again. So get low and protect your head. Now, in order to do the tornado dance, I have to pretend a couple of things. First thing I have to pretend is that it's really, really hot outside. Just a hot, sweaty, sticky, steamy summer day. That's the first thing. Second thing I need to pretend is that the Denver area is down here at my feet in miniature. Little tiny Denver down here. Little bitty Rocky Mountains back here. Little bitty downtown Denver right there. You get the idea. We're down here. When it's really hot outside, here's what's happening in the weather. Here's what's going on meteorologically speaking. When it's really hot, what we have is a great big bubble of hot air that's parked itself on top of Colorado. A great big hot air mass. If you want to be more scientific about this, a great big blob of hot air. Okay. I will play the role of the big blob of hot air. I know some people would say that that's an easy part for me. So I'm floating over Denver like this. Great big blob of hot air, and everybody down below is hot and sweaty and uncomfortable and miserable. And I, as a great big blob of hot air, I am very, very happy about this. Because this is what blobs of hot air do for a living. I'm just doing my job, making people hot and sweaty. So I'm up here saying to myself, man, this is great. I love floating over Denver, making everybody sweaty and miserable. You know, I don't think I'm ever going to leave. I'm just going to stay right here, stay here for years. Great big blob of hot air. Okay, well now let's pretend that we are up in Canada. Now, boys and girls, if we are in Canada and if we are air, we're going to be a lot different than the air that's down over Denver. We're farther to the north. We're farther away from the equator. We're closer to the North Pole. We get less heat from the sun. Our temperatures are lower. So if you are Canadian air, what are you going to be like? You're going to be chilled, right? Or as I like to say, if you are Canadian air, that means that you are cool. So this cool air is kind of hanging out in Canada, checking out the Canadian scene. And the cool air finally says, you know, I am way too cool to be stuck up here in Canada. I'm going to cruise on down to Denver and cool everybody off. So the cool air leaves Canada, starts heading down toward Colorado. Cool air's getting close to the hot air, and the cool air goes, hey, hot air, why don't you clear on out of there? I'm coming in to cool everybody off. All right, boys and girls, while the cool air is moving in, what's the hot air doing? Is it moving out? No, it's hanging out. It likes it. It doesn't want to leave. So the hot air's like this. Hot air looks over at the cool air and goes, no way, man. Get lost. Go back to Canada. You're not getting me to leave. I'm staying right here. My friends, we have a problem. Hot air doesn't want to leave. The cool air knows that it would be uncool to chicken out and go back to Canada. So the cool air says, now wait a minute, hot air. You've been there long enough. Time you clear on out. Matter of fact, if you're not going to leave, I am going to make you leave. And the cool air starts pushing on the hot air to get it out of the way. The hot air's kind of big, though, so it's like, whoa, come on, air. Hot air's getting pushed around like this. Hot air doesn't like that too well. Hot air finally gets fed up with it, and the hot air goes boom and throws an elbow at the cool air. Cool air catches his elbow, knocks him backwards like this. Cool air is not going to take that line down. Cool air comes back and gives a bigger shove to the hot air. Hot air comes back with a bigger shove of the cool air, and pretty soon these two air masses are really going at it. Big shoving match going on between these two different kinds of air. Whew. You didn't know this was going on out there, did you? This is why weather is so exciting. This big shoving match between the two air masses occurs along the cold fronts that I show you on TV, those little blue lines with the blue points. As the two air masses are shoving each other back and forth, here's what happens. The cool air is slightly heavier than the warm air, and it begins to wedge under the warm air mass, forcing the warm air to rise. That rising air is what builds up into great big thunderstorm clouds. The air inside of a developing thunderstorm, we call it the updraft, goes up through that thunderstorm cloud like smoke goes through a chimney, which is why thunderstorms get to be so tall, so high in the sky. Now, everything I've told you so far will give you a big thunderstorm, thunder, lightning, hail, rain, but it will not give you a tornado. There's one more thing we need for the tornado, and that thing is the jet stream. Boys and girls, if the jet stream is blowing over Colorado at the same time the thunderstorm forms, here's what can happen. The air rises through the thunderstorm like smoke through a chimney until it gets up to the jet stream. The jet stream racing by causes that thunderstorm cloud to start to turn and to start to spin very slowly. And what we find is that the entire thunderstorm will begin to spin. We call this a supercell thunderstorm, a rotating thunderstorm. Now, if you've seen a figure skater on ice skates doing one of their spins, they start with their arms way far apart like this, and they're spinning kind of slow. But as that skater begins to pull their arms in, they start to spin faster and faster and faster. The same thing happens in the thunderstorm. The air rises up, hits the jet stream, starts to spin. That spinning starts out big and slow, but then gets smaller, faster, faster, smaller, and the tornado forms down to the ground. Now, I'm going to get all tangled up in my microphone cord if I do it this way, so I have to put the microphone over here for just a second. I'm going to do the whole thing for you really, really fast. So just give me 1 second here, okay? All right. So here we go. If you want to join me at home, you certainly are welcome. So, here we go. We start with the hot air floating over us like this. Everybody down below is hot and sweaty and miserable. Oh, yeah, baby. Meanwhile, up here in Canada, the cool air starts to cruise on down to cool us off. Cool air's coming in. Hey, hot air, why don't you clear on out? Hot air's over here going, no way, man, get lost, go back to Canada. Cool air won't take that for an answer, starts pushing on the hot air to get out of the way. Hot air's getting pushed around, doesn't like that too well, so boom, throws the elbow. Cool air catches the elbow, knocks him backwards. Cool air won't take that line down, comes back, gives a bigger shove to the hot air, big shove to the cool air. Pretty soon these two air masses are really going at it. Big shoving match going on. Big thunderstorms build above the shoving match between the two air masses. The air in a thunderstorm goes up like smoke through a chimney, but it gets to the jet stream, zoom! Whole thing starts to spin, big and slow at first, and then much like the figure skater, smaller, faster, faster, smaller, and that rotation forms way up in the cloud and drops down to the ground to form the tornado. And that is the tornado dance. There we go. I have to tell you, teachers, a few years ago they invited me up to Leadville, Colorado, to speak at the grade school and do the tornado dance at 10,500 feet. Kind of blacked out after that. I don't remember much. But I think now, I used to be like an EF5, but with age I'm becoming more like a 2, so I'm a kinder, gentler tornado. Okay, one more quick thing I want to share with you, and that's about hail, because we are now getting into the hail season here in Colorado. If you think about what I just showed you in the tornado dance, you get the idea that the inside of a thunderstorm cloud is a pretty rough place to be. The winds in that cloud are going up and down and spinning all around. What that means is if you were a raindrop in a thunderstorm, you wouldn't fall straight down to the ground. Instead, the swirling motions inside of that cloud would take you for quite a ride. And as a raindrop in a thunderstorm, you'd go up and down and spinning around the inside of that thunderstorm like you're on a giant roller coaster. A roller coaster 10 miles tall. So high up that even on the hottest summer day down here, it's way below 0 degrees up there. So when those raindrops get blown to the top of the cloud, they freeze into little tiny hailstones. As they get blown around up there, those raindrops and hailstones run into each other and start freezing together, forming a bigger and bigger hailstone. The rule is the bigger the hail, the stronger the thunderstorm. So hail starts out really tiny, like the tip of a pencil, and that hailstone gets blown around inside that thunderstorm cloud, adding layers of ice, getting bigger and bigger until the hail grows to become the size of a golf ball. Now, if it's really a strong thunderstorm, the updraft in that storm is powerful enough to keep the golf ball size hail blown around up there, adding layers of ice, getting bigger and bigger until the hail grows to become the size of a baseball. If it's really a powerful thunderstorm, the winds in that cloud are so strong they can keep baseball-sized hail blown around up there, adding layers of ice, getting bigger and bigger, and the hail can grow to become the size of a softball. Would you like to see a model, a replica of the biggest hailstone to ever hit the United States? This is a plaster model of a giant hailstone that fell on Aurora, Nebraska a few years ago. It landed in a farmer's field. It dug a foot-deep crater in the ground. And when the storm moved far enough away that he could safely go outside, the farmer went out with a shovel, dug up the biggest one he could find, and stuck it in his freezer. This was probably bigger. Some of it melted before he had a chance to get out there. Needless to say, if there's big hail falling outside, where should you be? Inside would be a good idea. This would certainly wreck your day. So my friends, the next time we have a hailstorm, I want you to think about hail as a sign of a really strong thunderstorm. But another way to think about hail is that hail is simply Mother Nature's most amazing juggling act, with those hailstones going up and down and all around the inside of that thunderstorm, adding layer upon layer of ice, getting bigger and bigger and bigger until finally the hail is so big and heavy it comes crashing down to the ground. And that is how we get hail. All right. You guys have been a great audience. I really appreciate you listening so far today and for the last few weeks. And I want to talk about one more quick thing, which we did talk about a couple of weeks ago, but I'll touch on it again briefly, and that's very important. And I want you to hear the truth from me, and that is global warming and climate change. Boys and girls, the planet Earth is gradually getting warmer, and the reason is due to something that's called greenhouse gases, especially carbon dioxide. Carbon dioxide is in the room right now. We breathe it in and out all the time. It is not poisonous, but it is very good at trapping heat from escaping into outer space. And you can think of each little molecule of carbon dioxide like a little feather in a down comforter that's getting thicker and thicker, trapping more heat from escaping into outer space. When you trap that heat from the sun from escaping back into outer space, that means the planet gradually gets warmer. Now, that doesn't mean we won't have winter, won't have snow. Winter's a season, and snow would be a storm. But the climate of the planet Earth is gradually warming up because as we burn gasoline in a car or coal in a power plant, part of what goes out the smokestack is carbon dioxide. So we're gradually adding it to the atmosphere, and that's going to cause the planet to continue to warm. It's that simple. Add heat, get warmer. It's serious because as the planet gets warmer, we're going to see more of the glaciers in Greenland and Antarctica melt into the ocean. It's going to cause the sea level to rise. We don't live close to sea level, but about 1 billion people on the planet do, and that's going to be a very serious problem. Also here in Colorado, it's going to mean our droughts may be longer and more severe, but also will amp up severe weather. We could have stronger floods and other weather situations as well. So it's going to just kind of increase the severity of things. So it's a serious problem as well. But I am optimistic. You know, we didn't have these smartphones. Mine's not even very new, but these didn't exist 20 years ago, and they have the power that a supercomputer had just 25 years ago. A computer would fill a room, and now we carry them in our pockets. Boys and girls, in my lifetime, I've seen amazing inventions, and I've seen us go to the moon. In your lifetime, there'll be even more amazing inventions, and you know who's going to invent them? You guys are going to be the inventors. You'll be the scientists, the climatologists, the meteorologists, the political leaders, the inventors that will solve the problems that we face in the future. And so, ladies and gentlemen, moms, dads, teachers, let's give these world changers a round of applause for the wonderful things they will invent in the next 25 to 30 years. But the way we're going to get there is by paying attention in school and learning as much as you can. Now, sometimes I know that it's sometimes a little scary to ask a question because you're afraid you're going to get embarrassed. And so what I'd recommend, boys and girls, is if you have a question about something, and maybe it's something a teacher's been trying to teach you and you didn't quite get it. Well, teachers are always learning as well. So if you don't want to ask the question in front of the whole class, go to your teacher afterward privately and just say, I didn't quite understand what you're trying to say. Can you try and teach that to me in another way? That makes your teacher better because there are many ways to teach. It will also make you understand things better. So never be afraid to ask questions. Even if that question seems like it's a silly question, if it's a question to you, it's worth asking. And by asking questions, that's how we better understand our world, and we learn, and we can improve things in the future. You guys have been great. I appreciate everybody tuning in for Weather Wednesdays. We'll have another Weather Wednesday next week. And have a good rest of your day. Stay safe out there. You can always get in touch with me at mike.nelson@thedenverchannel.com. That's my email address. My Facebook is Mike Nelson Denver 7, and you can follow me on Twitter at Mike Nelson 247. Everybody have a great, safe day, and we'll see you again soon for Weather Wednesday.